All right. Last time we ended with continuous compounding. We said the future value, present value, e to the power RT, and that was the thing we ended up with last time. Of course, most of you didn't show up. Actually, none of you showed up. I was talking to myself, except for the people online. So that's what happened. But in any case, if you were online, then you already seen that. I'm not going to repeat what I said. So you want to watch it, it's already on Blackboard. So let's go ahead and do an example on this one and move on. So suppose you want to deposit, you deposited $1,000 at 4% compounded continuously for a period of 4 years. Question is, how much money you have, how much will you have in 4 years? In order to figure out how much money you have in 4 years, this is the important thing. It's compounded continuously, right? Just to know which formula we want to use. For this particular problem, we're going to use this formula, which I have written on top. So in this case, the future value is the present value, which is whatever you started with, E 0.04, that's your R, change into decimal, and T is 4. So then you would do the calculation for that, and let's pull out a calculator because say 1,000 E 104 times 4, that should be 1173.52. 1173.51. So this is how much money you would have in 4 years using that particular amount. Yeah? Any question on that compound interest? No? Another problem I thought that you might see on a test or on a homework. Let's talk a little bit about that. Okay. It says inflation is 3.5% per year. So we have things that increase at a rate of 3.5% per year. So another way, prices of things don't stay the same. Yes? Every year prices change. Most likely they go up. Things go up in price, and we call that a little bit inflation. So basically, suppose an item costs some amount of money today. The question is, how long would it take an item to double in price? Let's say an item costs $1 today. How long would it take, based on that inflation, how long would it take that item to cost $2? Well, we treat inflation basically like we treat compound interest, compounded annually in this case, since the inflation is happening once a year. Yeah? Since inflation is happening once a year, let's go ahead and treat that as compounded interest and compounded annually. Yeah? So if today's price is, let's say today's price for an item is, let's call that P. For any item, it has a price P value, correct? To double that price, then the future price would be how much? To what? $2 if it was only $1. We didn't say it was $1, did we? I said it is what? P. Then to double it will be just simply what? 2P. Yeah? Okay? So now we're going to use the formula for compound interest. The future price is equal the present price, the price at today's time, times 1 plus r over n to the power nt. All of these are the same. Yep. We said the prices or the inflation happening once a year, right? So in this case, n equal to 1. Yeah. And let's go ahead and substitute our numbers. So future price is 2p. So 2p equal p times 1 plus 0.035 to the power t. Yeah. Because again, n is 1. So nt would be t. Yeah. Now, our interest is this thing over here. To solve for it, step number 1 is I want to isolate all that exponential term by itself. Yep. To isolate it by itself, notice this term or this factor is multiplied by p. So to isolate it, I'm going to divide by p. Yes? So let's divide by p over here. Let's divide by p over here. When I divide by p, this p and this p happen to cancel out. And what happened to those two? They cancel out as well. So what does that tell me? There's no more p's left. It doesn't really matter what the price is. Yes? It will take the same amount of time to double. Okay. So what is that? Let's continue over here. So what's left is 2 equal 1.035 to the power t. Yep. To solve for t, we said by using exponential form, we can introduce log to bring the exponent down, yes? Because this t is in the exponent, and I do want to bring it down to solve for it. So I will use log, whether you use log or natural log, will be either the same way. Okay. Both of them the same thing. So let's use ln of 2 equal ln of 1.035 to power t. Now, we're going to bring t down. So ln of 2 equal t times ln of 1.035. Now to solve for t, we're going to divide by ln 1.035 divided by ln 1.035. The final answer would be t equal ln of 2 ln of 1.035, and I believe that should give me 20.149. So it will take, based on that inflation, it will take about 20 years, yeah, for the prices to double up. And that means all the prices to double up. Whether an item costs a penny or an item costs $1 million, it will take 20 years for the first one to be 2 pennies and the other one to be $2 million. Okay? Any question on that? No? All right. I didn't mention anything before I start recording on the test. The test, it was due this week. I'm going to delay it till the next week. But I'm going to leave the review open. So you can start doing review from now. Or you should have started last week, but it doesn't matter. Okay? So any question on any of these? No? All right. Let's move on then. So that takes care of some of these things. So effective rates or annual percent yield. APY. Okay. Effective rate, or sometimes called annual percent yield. If you have a credit card, if you do a credit card, if you ever look at the statement on the credit card, it's probably going to say something like, say, 6% nominal rate, right? But then underneath it, it will probably going to say 6.16 APY. So you will see on the statement, even though there are two different rates, but they are equivalent. What do we mean by equivalent? Okay, and what do we mean by annual percent rate? Okay. So effective rate, by definition, is the simple interest rate that produces the same interest amount as the nominal rate in 1 year. Interest rate or effective rate is the same interest rate that produces, it's a simple rate that produces the same amount of interest, right, as a nominal rate in 1 year. Another way, let's go ahead and give an example. Maybe we'll understand it with an example. Suppose you deposited $100 in a bank account that pays 6% 6% compounded monthly. Yes, compounded month. Because this percentage is compounded monthly, it's a nominal rate. Yeah, this is your nominal rate. So any compounding period other than a year, that will be equivalent to nominal rate. That will be the same as nominal rate, right? The question is, how much will you have in 1 year? We're just going to do for 1 year, okay? So we're just going to do the calculation based on 1 year. So let's see. The future value then is equal the present value times 1 plus r over n to the power nt. That's basically the future value for that. So let's substitute those numbers. Present value is $100 times 1 plus, or in this case, 0.06 divided by 12. N is 12 because it's monthly. NT is 12 times the number of years, but since it's only 1 year, so that will be 12. Yeah? And if we calculate this, I believe we should end up with 106.60. So that will be $106.16. Correct? Now notice, even though it's 6%, right? Because of the fact it's compounded monthly, we ended up with 106.16, right? So in 1 year, it was 6.16%. Does that make sense? Yeah? So I can say, if I will take the same $100, if I take the same $100 and deposit it at, say, 6.16%, but now compounded annually, after 1 year, I'll have exactly the same amount. Does that make sense? So what do we say? We say then this rate, and that rate are equivalent to each other. Why? They give me the same amount. Does that make sense? So what do we say? That's what you see on your credit card. Why? Because your credit card charges you monthly. Yeah? Always the APY is more than what the nominal rate is. Even though you make a deal with a Discover, they say, oh, we only charge you 3.9%. But then when you get the bill, you will find it says 3.9%, but you will also see another APY that says a little bit more than 3.9%. So this is the difference between the two. Yeah. What's the relationship between the two? Is the relationship so the effective rate R effective equal 1 plus R nominal divided by N to the power N minus 1. Yeah? Your book uses, I believe, M instead of N. That's one. Okay? But I like, since we've been using N for the compounded period, I just want to specify N to say this is exactly the same thing. Okay? This is exactly the same thing. So once you do this, you will find it to be the relationship between the effective rate and the nominal rate. So if I substitute the 6% compounded monthly, so if I say if Rn is 6% compounded monthly, then the RE effective would be 1 plus 0.06, divide that by 12 to the power 12 minus 1, and I should end up with exactly yeah. So that should give me that amount in terms of, now you will get the amount in terms of decimal form, then you have to change it to percent form, and then you will get the percent form. Any questions? No? Go back to the future value equal the present value, 1 plus R over N, our NT. That is the future value for compounded interest. Yeah? Well, not all the time we want the future value. Sometimes we need the present value. Yeah? So to figure out the present value given the future value, then PV is equal to, if I were to divide both sides of the equation by this term, we end up with the future value by 1 plus R over N to the power NT. Okay. So far, so good. Any questions? Now, how do I use this formula? Well, suppose for instance, you wanted to have $15,000 in, say, 5 years. So we need 15,000 in 5 years. Say, for instance, you found a business proposition in which that pays you, let's say, 4% compounded monthly for at least 5 years. For at least 5 years. They will guarantee that for at least 5 years. And the question is, how much should you invest so that in 5 years you will have your $15,000? Okay? So how much would you invest to get the required amount? How much should you invest to get the required amount? Well, simply the required amount, I'm going to invest it today, right? So that's your present value for the money you're going to be getting in the future. Because those you're going to invest them today, and then you're going to get them back in the future. So the present value is equal to the future value divided by 1 plus R over N to the power NT. And I can go ahead and substitute those numbers so I can figure out how much should I invest today for that. So again, the future value is the money I want to get in 5 years, which is in this case, I wanted to get 15,000. So this is your 15,000. 1 plus R, which is 0.04 divided by 12, because it's compounded monthly, to the power 12 times 5, because 12 is the compounded period and 5 is the number of years. And once you calculate this amount, I don't know how much it's going to be. Somebody to calculate that amount for me. So we have, you clear that? 15,000 divided by, oops, how did I make a mistake? Divided by 1 plus 0.04 over 12 to the power 60. So that should give me 12,285 and 5 cents. So that means I can invest today, and using this proposition, right? I can invest today $12,000, $285, and then in 5 years, I'll have exactly those money grew to $15,000. Okay? So I will have whatever it is I want in that amount. Clear? Any questions? We're gonna move on to annuity. But before I move on to annuity, I want to show something that will make it easier for us to understand the formula for annuity. Suppose I want to multiply x minus 1, and I want to multiply that by, say, x to the power, say, 6, 5, I'm going from a certain exponent down to it is constant. Yes? Using an exponent. Now notice those exponents are descending one at a time. And we're multiplying that by x minus 1. So when I multiply, what do I get? Now, when I multiply by x, I'm going to get the same thing, except the exponents are going to be one more. Because x to the power 6, you multiply by x, you add the exponent, you got one more. Yeah? So the first part of the multiplication by x, we get x to the power 7, 6, 5, 4, 3, plus finally x. I'm sorry. No more ones. Yes? Because 1 times x is x. Yes? Now, when I multiply all of these by negative 1, multiplying by 1 doesn't change anything, right? But multiplying by the negative makes all the positive to become negative. Okay? So let's write them down. So the first small product is x to the 6. Now this is minus x to the 6, minus x to the 5, minus x to the 4, x cubed, x squared. Yeah? Now, When I multiply these, what do I get? X to the 7, there is nothing to add with it, so that's x to the 7. And notice all of these, what happened to them? Plus or minus, they cancel, right? These two cancel, these two cancel, these two cancel, these two cancel, these two cancels, what's left? Okay. So that's basically, if I have, say, this term by itself, and I multiply this term by that, and then I divided it by x minus 1, it's still the same thing, right? So if I put this over x minus 1, that's still going to give me Is that correct? Yeah? Are we clear on that? So with that, we might keep that in mind, keep it handy, because we're going to use it to show the formula for annuities. For annuity deposits, what you're doing is you're probably making the same deposit over and over again at a certain period of time. Say, for instance, we just talked about saving money for the future for $15,000. Normally, it doesn't find like, let me find an investment and then invest the money or what have you. Normally, what you would do is you would look at your budget and say, oh, I can afford to put that much money, or you want to know how much money you should put in the bank to get that, right? So you can, from your budget, you can say, I can allocate, say, $100 every month, put it in a saving account, and then at the end of 5, 10 years, this is how much you're going to have. Or if you are working and you have retirement plan, what do you do? If you have a salary base where your salary doesn't change, you're doing every month, you're taking out exactly the same amount from your account, and you put it into your retirement plan. Does that make sense? Okay. So basically, let's say we have certain type of annuity. Let's say, I'm just gonna say 6 period, nothing more. I'm just gonna go for 6 period, yes? And you decided to deposit one amount at the end of every period. Yeah? So for example, this is the beginning of the period. This is your end of the period, right? You deposit a certain amount of money. Let's call that P. Okay? So that means at the end of this period, it is part of P, this is 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 P. Yes? Now, you are depositing at R%, whatever R is. Whatever R is. Yes? Compounded exactly what that period is. Okay? So now we're going to go ahead and figure out how much money we have after 6 periods. So we're only going to go for 6 periods on that. When I deposit this money today, this money stayed in the bank for how many periods? Let's say stayed 1, 2, 3, 4, 5. So it stayed in the bank for 5 periods. So that means I got interest on this one. Correct? How long? How many times? 5 times. Does that make sense? So the future value for this amount is P times 1 plus R over N to the power, in this case, it was 5 because it stayed for 5 periods, yes? Remember, the exponent is always the number of periods, yes? Just what? So far, so good? So that's the future money of this money. Yeah? What's the future money of this one? It will be the same thing, except the period. How many periods is this days? 4. Yes. So that's going to be, we're still going to start with the present value, which is a P, 1 plus R over N to the power 4. And you see where we go into with that? So the next one would be how long? 3. Now, we're here, right? What's the last one? It didn't stay in the back. I just put it, right? Because it's the end of the period, correct? So, plus whatever I deposited last time. So that's 1, 2, 3, 4, 5, 6. And 6 of them. Yes? So just to make things a little bit easier and not writing a whole lot, let's call this portion over here X. Let's call that portion X. So I don't have to write the whole thing. I just write X, and we know X is representing all of this. Yes? So now what do I have? We have a P in common, don't we? In all of them. So I can just simply factor it out. So P times. Well, here we're left with X to the power 5 plus X to the power 4 plus X cubed, X squared. Yeah? That's too many numbers to put down. Let's simplify this a little bit. What I'm going to do is, I'm going to multiply by X minus 1. Okay? But then to keep it the same without changing it, I also need to do what? Divide by X minus 1. Yeah. Clear so far? Okay, now let's see what we end up with. P is by itself, still the same, right? Now, didn't we just do this? Didn't we just multiply these out? When I multiplied them, what was the final answer? Exponent 1 more on that, yeah? So that should give me X to the power 6 minus 1 divided by X minus 1. Okay? Well, let's put our X back. We're done using X. Because now we need to figure out what the formula is. So equal P times, we have X is this, 1 plus R over N to the power, oops, yeah, 6 minus 1 divided by 1 plus R over N minus 1. Isn't that what this is? And now notice what happened with these two ones. 1 minus 1 is 0. What's left? R over N. So P times 1 plus R over N to the power. But what was 6? Wasn't that the whole period? Yes? In terms of formula, 6 would have been, since we did it, let's say 6 months, right? 6 would have been 12 times 1 over, times 1 half, right? Which is a half a year, right? Which is NT. Minus 1 over engine six to NT. That's exactly what 6 is. 6 is number of period, compounded period times the years, which in this case, N, which would be 12 because compounded monthly, say, yeah. And then T would be half a year because it's only for 6 months. Yeah. And this is your future value formula for annuity. Okay. Let's do a little example. Okay, I'm doing section 5.3 in the book. So let's say you're depositing let's say you're making a deposit of $1,500. Let's say you're making a net deposit of $1,500 into an account. Let's do that much. Into an account that pays, say, 8% compounded monthly. Notice, compounded period, and the deposits are exactly what? They're same. Question is, how much you will have in 6 months? How much? Do you have in 6 months? Well, use the formula. So the future value equal the payment. Payment amount is how much you make in every time, how much you deposit in every time. Okay? Just to differentiate it from the present value, we're going to call it payment. Yes? Times 1 plus R, which is 0.08 divided by 12. Yeah? NT in this case happened to be 6 because 12 times a half a year is 6 minus 1 divided by 0.08 over 12. So this is 1500. So now, let me see if I can figure out that amount. Did I use the same amount over here? Nope. Okay. So we have, let me clear that, 1500 parentheses 1 plus 0.08 divide that by 12 to the power of 6 minus 1, divide that by 0.08 over 12. It should give me $9,151.34. Well, you should have in the bank at least your deposits, yes, which is $9,000. Provided I did all of the calculation, my phone is tiny, I can see properly on it. But provided we did all the calculation correctly, it looks like I entered it correctly, then in 6 months, you should have $9,151. Okay. That's it for today. Again, your test will be due next week. I'll go ahead and change it sometimes this week. But it's going to be the same rules. You're going to have to go to the lab and take it over there.